Hi everyone, Mrs. Below here. In this video, I'm going to be going over limiting reactants in the Chapter 9 notes, slides 18 to 20, just to introduce this idea. So a limiting reactant by definition is something that is completely consumed or used up during a chemical reaction. So if you are reacting two things, so let's say A and B together to make AB, and A gets used up first, well, that's going to limit then how much product you can make of the AB product. So remember, reactants, those are on the left side of a chemical reaction and products are on the right side. So typically in a chemical reaction, you'll have two things that are reacting together, and one of those will get used up first, and that's going to limit how much product you can make. Sometimes it might be one product, it could be more than that, it could be two products, depending on the type of chemical reaction. And then therefore, if A, let's say, got used up first and was the limiting reactant, there would probably be leftover of B then, meaning because it didn't get used up in the reaction, and that would be the excess reactant. That's the reactant that remains after the chemical reaction stops because it didn't get used up first in the chemical reaction. So we can use stoichiometry to figure out what reactant will limit how much product we can make. So here we have methanol. It's a very simple alcohol, and it's produced by this chemical reaction here, hydrogen gas and carbon monoxide being combined together. So let's say we know how much of, and this is how scientists can predict, theoretically how much, product can we make based on the reactants that we have. So we're going to be given the amounts of both these reactants. So we have 500 moles of CO and 750 moles of H2. And we need to figure out which of those is going to limit how much product we can make. So what you want to do is you want to convert both of these reactants, right? Each of those is the reactant, into the same product. I mean, that's what we've been doing with stoichiometry, is we've been using the equation to convert between the different substances that are involved in that chemical reaction. So if we convert both of them, so we're going to do two picket fences, if we convert both into this product, because that's what the question is about, and it's the only product in the question, then we can see which one will make less product and therefore would be the limiting reactant. So when we do these problems, you're always going to have two picket fences. So we're going to have one for one of the products, so 500 moles of CO. And then we're going to have another one for the other product, the other reactant, 750 moles of H2. So we have two picket fences, one for each reactant that we were given. And we're going to convert both of these reactants into the same product. And for this question, there is only one product for us to convert into. Sometimes there could be multiple products to pick from. If the question doesn't specify which product to convert into, then you could pick either one. As long as you're converting both of these into the same product at the end, then you can compare them to see which would have theoretically made less product. So in a picket fence, if I have moles of CO here, I know moles of CO have to go in the bottom. Now, in terms of how many, this is when I can use the equation. If you're ever starting with moles, you can go straight into using the balanced equation. And in this balanced equation, there's a 1 that's implied being here. So that would be 1 mole of CO. That's where I'm getting that number from. And then the thing that goes above it is what I'm trying to convert into, which is the product. I'm trying to convert both of these reactants into the same product. And there is only one product to pick from, and that is the CH3OH, which is right here. And there's a 1 there that is implied. Now, this one's really easy for the math because it's 500 times 1 divided by 1. So this would be then 500 moles of CH3OH. These cancel. So all I did was a moles to moles picket fence. I converted moles of CO into moles of CH3OH, which was the product. And theoretically, so this is everything we've been talking about with these picket fences is theoretical, because this is like in a perfect world, this is how much product it would make. So this 500 moles of CO would produce 500 moles of CH3OH. Now let's see the other reactant, which is hydrogen. So I know that moles of H2 has to go here for the units, and then I get the number from the balanced equation. So we have 2 moles of H2. And just like the last picket fence, I'm going to convert this into moles of CH3OH. We're converting both of these into the same product because we want to be able to compare them to each other. So this time I have 750 times 1, which is 750. And then we're going to divide that by 2. So 750 times 1 divided by 2, which is going to be 375 moles of CH3OH. So the 500 moles of CO would produce 500 moles of CH3OH, theoretically. And 750 moles of H2 would produce 375 moles of CH3OH. So this isn't my final answer. This is just the work to get to the final answer. My final answer is, when I look at both of these, I can see that this one is less, right? 375 is less than 500. So theoretically, I could only make this much CH3OH because the H2 is going to be I'm going to write LR for limiting reactant. If you want to write out limiting reactant, that's fine. I'm okay with students shorthanding it. So that would be my final answer. H2 is the limiting reactant because this is making less product in comparison to the CO. So theoretically, this is the most product I could make because the H2 would be used up first, and it would be used up, and then we would have leftover CO. So theoretically, this is the most product I could make if I was given these amounts of reactants, and therefore H2 is the limiting reactant, right? Reactants are on the left-hand side of the equation. H2 would limit how much product we would make.